So we're going to have an introduction to Boyle's law. So I've got this simulation here which is produced by Fett from the University of Colorado, and what we can see is we've got a pressure gauge and there's a thermometer here. I can pump some gas molecules in, and we've got this little dude over here, I think his name's Norman, and he's going to push back against the pressure of the gas inside there, because obviously we've got a vacuum on the outside. So let's stick some molecules in. There we go, and I think we're going to put a few more in. Yeah, let's have another wallop. Perfect. Now you can see that we've got a temperature in there, and we've got a pressure of 0.69 atmospheres. I can't really read it, my screen's a bit small. So and what I've done is I've gone over to the right hand side and I've said for Boyle's law we must keep a constant temperature. So what I'm now going to do is I push the side in, so I've lowered the volume, and just like with the fire piston, the temperature will increase, but as we let it cool down you'll notice that the pressure has increased. So we're going to again reduce the volume, temperature's gone up again, wait for it to come back down, and again the pressure is increased. And just finally we're going to go for the extreme version. We're going to push this all the way in, so now we've got a really small volume, and again wait for the temperature to come back down to 300, and you should see that the pressure has gone up. So what our Boyle's law is showing us is that as the volume decreases, the pressure increases. So writing that down more formally, Boyle's law states that for a constant amount of gas at a constant temperature, the volume is inversely proportional to the pressure. Now if we have a look at how we would write that out more formally and mathematically, the volume is inversely proportional to the pressure, and conversely the pressure is inversely proportional to the volume. And another way of looking at that is if I was to multiply the pressure and the volume together, they will always equal the same number. So now we're going to have a look at what Boyle's law looks graphically. So if I was to plot pressure against volume, as the pressure decreases the volume will increase, and this gives us this curved shape graph. And then if I were to plot pressure against 1 over the volume, now this should be directly proportional, so I would get a straight line passing through the origin, looking something like that. So now we're going to have a look at an example calculation. We're going to have a fixed amount of gas is kept at a constant pressure. The volume of the gas is 3 litres and at 100 kilopascals of pressure. The gas is compressed to a volume of 0.5 litres. What is the new pressure? So to begin with, we know that PV is always going to equal a constant. So if I was to look at the conditions to begin with, P1 times V1, they must equal the conditions afterwards, P2, V2. Now if I rearrange this equation to give me what the new pressure is, P2, so that's then going to equal P1 times V1 divided by V2. Now if I substitute my numbers in, I'm going to have a volume of 3 multiplied by a pressure of 100 kilopascals. Notice with these, when you're doing this proportionality, the units don't matter as long as they're all the same on either side. So 3 times 100 divided by 0.5, have a quick tap on your calculator and you should get an answer coming out of as 600 kilopascals. Okay, over to you to have a go.